London, and I'm doing a little tour of Asia. So I started with Ho Chi Minh City and Hanoi, Jakarta, then I'm going to go to Singapore. It's always great to be in Asia for me, because if you know anything about London, you know that the weather is horrible. So every time I come to Asia, it's much better weather, so it's great to be here. And I also like to reach out to the world who is in this part of the world as well, because I don't like to, Google being a US-based company, sometimes we forget that there's a whole world out there. So I think it's very important that we come out of US and Europe and go to other regions and make sure people are up to date with technology. All right, this is my Twitter. So I tweet about things like Kubernetes, Istio, Knative, and general Google Cloud stuff. So if you're interested, feel free to follow me. And just this morning, I open sourced my demo that I'm going to show you on GitHub, along with this presentation. So if you want the presentation and the actual demo itself, feel free to go to GitHub, it's already there. And I also have a little survey. So Knative it's a new serverless framework from Google that's built on top of Kubernetes and Istio. It just came out, and we just started talking about it. So I'm trying to understand whether people heard about it, and what they think about running serverless on Kubernetes. So I have a survey for like 5 questions. So if you have time, you don't have to do it now, but feel free to do it at some other time. It will be useful for us to know. And one last thing before I start. We have a startup program where we help startups with their technology, and we help them run on Google Cloud. And we have 3 different startup programs: Start, where you get $3,000, Spark, where you get $20,000, and Surge, where you get $100,000, depending on different criteria. So if you're part of a startup, or if you are thinking of doing your own startup, keep this in mind. And we actually have a special link for today. So if you go to this link, or if you scan this, then you can get $3,000 for eligible startups. So there's a team that basically will look at your application, and if you're eligible, your startup is eligible, you'll be able to get $3,000 to run on Google Cloud. So I'll just keep this for 10 seconds, and then I'll start with Istio. All right, good. Shall we start? All right. Let me just read one more grid. Okay, cool. All right, so first I start my talk with talking about why we even talk about Istio, and let me check time so I don't go over. All right. So why we even need Istio? So I talk about containers, and I talk about Kubernetes, and I talk about why they fall short and why we have Istio. But since this is a Kubernetes meetup, I will go quickly here, because I think most of you probably know about containers, and most of you know about Kubernetes. So I won't spend too much time, but just briefly, a container gives you a consistent context that you can replicate on your machine, or you can replicate in the cloud. That's what containers do. Docker gives you a way to define your dependencies, your environment, and your application in a Docker file. So in this case, it's a very simple example. You're depending on Debian latest, you're installing some packages, you're exposing ports, so you're setting your environment, then you're just running Nginx, you're running your application. So Docker made this possible. It gave us a framework to do this in a consistent way. But containers and Docker by itself is not enough, because when you run in production, you need redundancy, meaning you need multiple containers, so you need to manage them and maintain them. You need to scale up and down depending on the traffic. You need to worry about configuration and secrets. You need to worry about health checks. So how do you even know that your container is healthy? So that's why we have Kubernetes. You all know about Kubernetes. One thing that I'll tell you though, so you can see that Kubernetes it's a Greek word. Those are the Greek letters. But everyone mispronounces Kubernetes. And I know this because I'm originally from Cyprus, where Greek is one of the languages. So the right way of saying Kubernetes is Kubernetes. Kubernetes. Yeah. But Kubernetes came out in the US, and I mean, sorry if there's an American here, but most Americans, they tend to mispronounce foreign things. So they started mispronouncing Kubernetes to Kubernetes, so now we have stuck with the wrong name. So even though Kubernetes, at least you learned something new today. And in a really quick way, so in Kubernetes, what you do is you have your code in a container, you create a template, a pod template, which is usually a single container or multiple containers bundled together. Then you tell Kubernetes what you want to be true. So in this case, we're saying we want 3 replicas. Then Kubernetes looks at them and says, okay, these are my nodes. Let me find the right place to schedule these pods. We'll schedule them, and then we create a service to expose the pods to the outside world. The service will have the stable virtual IP, and then people from outside will get to your service and will get to the pods. So in this world, a microservice ends up becoming your code and a combination of Kubernetes working together, right? Which is great, but it's not enough either, because when you run an app in production, you definitely need logging, right? You need to be able to, see what's happening in your application when something is going wrong. You probably need HTTP tracing, so if a call is taking a long time, you want to be able to see where the time is being taken. It would be nice to see dependency visualization, so if you have multiple microservices, who depends on what? That would be nice to see. You definitely need metrics. So, like you want your services to emit metrics, and you want to collect them and display them somehow. And there's all these other things that you probably need. Sometimes you can ignore them, and it will be fine for a while, but eventually they will come and bite you, as some of you might know. So that's why we have Istio, right? This is the logo of Istio. So it tries to basically solve this kind of problems, okay? So hopefully this gave you a quick overview of like why we even need Istio. And Istio, it's, as you can see, it's another Greek word, because open source people are obsessed with Greek for some reason. But Istio, it's an open source project that's about managing the traffic of your containers. I mean, it says connecting, secure, managing, monitoring, but basically it all boils down to, you have your containers that are running, Kubernetes schedules them and make sure that those containers are running, but Kubernetes doesn't do anything for the traffic coming into your container cluster, right? So that's what Istio is trying to do, manage the traffic to your container cluster. So if you imagine that you have this simple cluster, container cluster, so you have users talking to the front end, then that front end microservice is talking to pictures and payments and authentication microservices. Authentication microservice is talking to an external database, and then maybe the payments microservice is calling an external payment processor. So imagine you have this. In this scenario, anyone can call anyone, right? So front end is not supposed, for example, the pictures is not supposed to call authentication, but no one is preventing that. Anyone can call anyone. You don't know what kind of traffic is going through here. It can be HTTP or HTTPS. You don't know what the rules are, so it's kind of like an open area. Like even though you have these microservices, like there's not much security in this scenario. Once you install Istio, this is what you get. So in Istio, first of all, you have ingress. So all the traffic coming into your cluster goes through the ingress, and you can set rules on the ingress, what's allowed and what's not allowed. So it's secure at the edge. And then all the traffic that's going out, you can also make it go through what's called an egress. So you can control things here as well. Or if you want something to go directly, you can do that as well. So it's up to you whether you want to allow this or not. And also every pod will get a proxy, right? And then this proxy, it's an envoy proxy that I'll talk about. The traffic basically in the cluster will go through the proxies. So if front end wants to call the pictures microservice, the proxy of the front end will call the proxy of the pictures, so on and so forth. And because the traffic is going through the proxies, a lot of interesting things can happen. Istio can do a lot of interesting things like traffic management and policy rules and stuff like that, right? So that's what Istio does, basically controls the traffic. I don't like to put too much text in a single slide, but this is a single slide with a lot of text. And the reason is, sometimes it's nice to have a single slide that explains what is something. So basically this slide explains what is Istio in a single slide. So it's something that runs on Kubernetes today. It's supposed to be platform agnostic, so they're trying to support it on different kinds of platforms. At least that was the intention initially. But so far it hasn't happened yet, right? So far Kubernetes is the main platform that's supported. 1.06 is the latest version, but 1.1 is coming soon. And it gives you first of all observability. So by default, when you install Istio, you get metrics for free. You get a way to query the metrics for free. You get a way to visualize them for free. You get HTTP traces for free, and you get dependency visualization for free. So by just installing this, and not changing your application, you get all of these observability features for free, and we'll take a look at them. Your services get strong identities, and they also get mutual authentication. So you can be sure that if a service calls another service, they are mutually authenticated, and you can be sure that it's actually that service is calling this service. And then you get a lot of traffic management features. This is the main part of Istio. So you can dynamically set traffic policies and control how the traffic flows in the system. You can set rules at the ingress and egress level. You can set timeouts. So for example, if you make an HTTP call, you can specify what the timeout should be and how many times it should be retry. And Istio retries that for you, so you don't have to do it in your code. And then you can do complicated things like fault injection and delay, so you can delay your calls for testing and things like that. And yeah, we mentioned the post enforcement. So this is what Istio is, and we'll go through them now, and I'll hopefully have time to show demos for all of this. So you can install Istio on pure Kubernetes. So if you're running Kubernetes locally, or if you're running Kubernetes on AWS or Azure or anywhere, you can install Istio on top of that. But in Google Cloud, there's something called Istio GKE add-on that makes it really easy to get a Kubernetes cluster with Istio already pre-installed, okay? And that's what I'm going to show now. But you don't have to use this if you're not on Google Cloud. You can install it yourself as well. It's just a little bit more work to install it on your own. So how do you get a Kubernetes cluster? In Google Cloud, you would say gcloud. It's still beta. The Istio add-on is still beta. So we say beta, container class is great, give your cluster a name, then specify your add-on, in this case Istio, then specify the configuration for Istio. So as I mentioned, in Istio, your services can be mutually authenticated. If you want that, you can specify MTLS strict, and this will make sure that your services are mutually authenticated, but you don't have to have that if you don't want to. And then you can specify your Kubernetes cluster, and the machine size of your cluster, and finally the number of nodes. So by having this single command, you will get Kubernetes cluster with 4 nodes and Istio installed with mutual authentication. So you have that running, and then after that you need to also set a cluster role binding. This basically enables Istio to manage your cluster, so that when you add Istio add-ons, it will be able to manage it for you, right? So basically just running 2 commands and you have an Istio cluster running. I actually have this running, so let me just show you here. So this is Google Cloud Console, and you can see I already have 2 clusters I'm running here, and these are I'll use one of them. I think Hello Istio in my demos. And once, and actually let's see. So here I have. Yeah, if you can, please. So what I'm going to do here is that I have. You can look closely. Yeah. Yeah. Is it big enough?
Yeah, it's fine.
It's fine. So I already have. Let's see. Let's move this here. kubectl get pods. Yeah, that's better. Yeah, so I install Istio. So if I do kubectl get pods, and everything when you install Istio, it goes into a separate namespace called Istio system. So when I do get pods Istio system, I should hopefully. Yeah, I see all the Istio pods running. So as you can see, they're all running or completed. And then if I do kubectl get services, then I see all the services of Istio running as well. And the important thing is that this ingress gateway, it has a public IP and a port. This is what we want to use to get into the cluster, right? So because Istio is watching the traffic on this IP and port, so that's what we're going to use to get there. So everything is working. Next, I'm going to talk about the building blocks of Istio, and then we're going to install an app and see what it takes to install the app. So I'll continue from here. All right. So Istio has, as I said, 2 parts. One is the control plane, and the other one is the proxy. So proxy it's called Envoy proxy. It's a separate open source project that Istio basically utilizes to route the traffic through. So it's the thing that does the work. Most of the features of Istio is implemented at this level, but the control plane, the things in the control plane, they can help the proxy to do its work, basically. So there's Pilot for discovery and config management. So if a proxy wants to talk to another proxy, it will ask Pilot, where is this other proxy, and Pilot will keep track of that. and then if we want to configure the proxies, we'll talk to the pilot as a user, and the pilot will take the configuration and push it to proxies. The mixer is all about policy checks and telemetry. So if a proxy wants to make a call to another proxy, it will first check with the mixer, can I make this call? Is there a rule that I should be aware of? And if the mixer says yes, then it will make the call. Otherwise, it won't make the call. And also, the proxies will emit metrics. All those metrics end up in the mixer, and then mixer will use them. We'll use those metrics to store them and display them in places like Grafana. And Citadel is about TLS. So if you want to set mutual TLS, Citadel is the one that will set that up, and it's the one that will issue the certificates and rotate the certificates and all that kind of stuff. So that's what Istio is in a nutshell. Let me show you how you would deploy an app. So first, So first we're going to deploy a simple hello world kind of application. And we need to create a Kubernetes service and deployment as if it's just a regular Kubernetes application. So what we're going to do is we're going to say kubectl apply service v1. By the way, I have this in my tutorial. So in my tutorial, I talk about creating a cluster and then global Istio. So let me just open this up just to make sure that I don't miss anything. So here I create my application, which is a hello world.net application. Then I create a Docker image out of it. I push it to Docker Hub. And then I create a service-v1 YAML. In this YAML file, I define a deployment for my application. So this deployment basically will create the pods. And then the service will expose this pod on port 8080. So this is the Kubernetes service that we're going to create. So I will just apply the service, and let's take a look what happened. So this created the service and deployment. But right now, let's see if I have the gateway URL set up. So this is the Istio ingress gateway. If I do this, nothing happens because we haven't exposed this Kubernetes service in Istio yet, right? We need to do that. So that will be the next part of Istio, because you have Kubernetes service, but you need to hook that up to Istio routing, and that's what we're going to do next. So let me just talk about that briefly. So right now there's nothing Istio specific, so we created a Kubernetes service and a deployment. We created a pod, everything is running, but we need to hook this up to Kubernetes routing API. And the routing API, there's a lot of building blocks there, but the main ones are ingress gateway, so that's where the traffic comes in, and I show you the pod that was running for ingress gateway. Then you need to create a gateway. A gateway is kind of like the front end to your application, and in the gateway you define, which protocol you want to expose and which port you want to expose. For example, in this case, it's HTTPS and port 443. In our case, it's going to be HTTP and port 80. So once you do that, you allow HTTP traffic into your cluster, but then you need to route the traffic to your Kubernetes service, right? You need to somehow associate that traffic to your Kubernetes service. And you do that with something called virtual service. So in virtual service, you basically do the mapping from the gateway to your Kubernetes service. And then there's also something called destination rule. So if your service has multiple versions, like version 1 and version 2, you can create what's called subsets for those versions. And you can further, once the traffic gets to virtual service, you can further route it to different versions of your service, right? And there's much more than this, but I'm just showing you the main parts: ingress gateway, the main gateway, virtual service, and destination rule. Those are the main things that you usually need to worry about. So let's do this. So what we need to do to define is first, I have the same thing here. We create the gateway. So we create the gateway. It's a YAML file, but the API is Istio. And then we give the name, we specify the port and the protocol, and we enable it for all the hosts. So everything that's deployed in Istio will be able to use this gateway. So this enables port 80 and HTTP in Istio, and we'll apply this. And the next one is the virtual service. In virtual service, first we need to associate this with the gateway. So we are saying that this is associated with the gateway, and then we need to specify which Kubernetes service this virtual service will map to. So in this case, this host is the actual Kubernetes service that created, right? So by doing that, we're mapping the gateway to the service. So let's do this. I think I can do this one hand. Let's see. Yeah, kubectl gateway. Oh, maybe not. Apply, right? That's me, right? Yes. So gateway is created. Virtual service is created as well. It's created. And now, if we go back to our curl command and ping the ingress gateway, and it says hello world. It's not that exciting, but at least we enable traffic to our cluster, right? Okay, so all we did is that we had a hello world application and we deployed it to Kubernetes and then we enabled traffic to it. So there's not much to it now. So at this point, you might be wondering, what the hell is with Istio? I can do this hello world on my local application, and you did this with all these virtual services and gateways. You know, what's the point? And so I guess this is the point of Istio now. From this point on, we set up for Istio. Now I'm going to explain the benefits of it. All right. So once you have your Istio running, you can install what's called add-ons. One of them is called Prometheus. Some of you might know Prometheus. It's an open source project, but basically Prometheus is for metrics. So you can install it by just basically pointing to a YAML file and just saying kubectl apply. And once you do that, you have deployment and service for it. And then if you look at it, you can see that Prometheus is running. And then once it's installed, then Istio by default emits some metrics, and you can see those metrics from the Prometheus dashboard. Then you can install Grafana, which is another open source project, that will let you visualize those metrics. Again, installing it is very easy. It's pointing to a YAML file. And then once you have that, once you send traffic to your application, because the traffic is going through Istio proxies, they will emit metrics automatically, and you will see those metrics in your dashboard. But this is a key point to understand. You don't change your code. You don't add metrics in your code. You just let Istio edit those metrics for you. So that makes it much easier to add on metrics to your application without changing the code. Then you can install Service Graph, which is another project that will give you the dependencies in your application. So you can see that there's ingress, then it goes to product page, then it goes to reviewers page, so you can see all the dependencies, and this updates in real time, so you can see the requests per second. Then you can install some tracing, like things like Jaeger and Zipkin, which is for HTTP tracing. Once you install them, you basically, when a request comes in, you can see how long each request takes, right? So you get these by just pointing to some YAML files and then everything enabled. So let me show that. So I actually installed these already. So if you look at the services, let's see. Yeah, if you look at the Kubernetes services, it's a little bit slow. But if you look at services, you should see like Prometheus and Grafana and all the other ones, hopefully. In the meantime, yeah, there you go. So you can see that Grafana is already installed and Prometheus is already installed. What we can do is, let me go to my tutorial. So to visualize the metrics, we need to set port forwarding. So let me just copy this and then go back here. And what I want to do is I want to first send some traffic to my cluster. Where is it? Okay, let's do this one. Yeah, so I'm just sending some traffic to our endpoint, so you can see that we get hello world. And then let's copy this. So I'm going to look at Prometheus first. So let's come here. So I'm setting port forwarding to Prometheus, so I can take a look at it from my machine. And then if you go to Windows 8080, I should add this skill to my CV. I can demo with one hand. So if you open port 880, you can see that Prometheus is already there. And then if we look at some Istio request, so you can see that there's Istio request bytes count. So this is already emitted by Istio, right? I didn't change my code, it's just done by Istio. We can do the same thing with Grafana. Grafana is a little bit nicer to look at. So I'm doing the forwarding again. As this is being done, let's go back here. Open it up. And then Grafana by default it comes with some dashboards. We'll look at the Istio service dashboard if it opens up. How much time I have, by the way?
You still have.
Okay. Because I still have a lot to show. Let me know. Yeah, the Wi-Fi is a little bit weak, so let's wait a little bit longer, and if not, then I will show you something else. Oh, broken pipe. Let's try one more time. Okay, this should work now. So now we are visualizing it from Grafana. We go here, there's Istio service dashboard. And then you can see like the request volume and then duration. And if you have multiple versions of your app, you'll see like V1 and V2 here. So you get this basically for free by just letting Istio manage your traffic. And the last thing I want to show in here, so the service graph to see your service dependencies. But maybe I can show it here because we don't have that much time. So once you do that, you will basically get your service dependency. So you can see like who's calling what, like this. And then if you install the tracing, then you can look at Jaeger or Zipkin and see your services and how long each call is being taken, right? So these are some of the add-ons, not all of them, but some of the add-ons that kind of comes with Istio. All right. Now let's talk about traffic management. So I think traffic management is one of the benefits of main benefits of Istio. So you just got this area and load balancing for services. You can dynamically change requests. So you can dynamically set rules about which requests should go where and enforce them using Istio. You can do failure recovery. So usually when you need to make calls from one service to another service, you need to specify timeouts. And if there's a timeout that happens, you need to retry it, or you need to maybe set circuit breakers, right? So you have to do all of that in your code. But when you're running Istio, you don't have to do that because Istio has all these concepts built in. So you just specify what should happen. For example, if you say, if there's an error, try it 3 times, Istio will try it 3 times before it fault strikes your application code. So you don't have to do this kind of logic in your application. And you can also do fault injection. So you can say, I want my 50% of my traffic to fail with HTTP whatever fault, right? And you can do that. Istio will do that for testing purposes. So, for example, you can say, my service A wants to call service B. So it will make the call to service B. This will go to Envoy. Then Envoy will ask to Pilot, where is service B? Pilot will ask Kubernetes, where is service B, and will find it. But the cool thing is that you might have a rule in Pilot that says, I want to send 99% of the traffic to version 1.5, but 1% to version 2. And behind the scenes, this will happen, but service A won't know about that. Service A will just make a call to service B, but behind the scenes, you're splitting the traffic. So this is kind of cool. The other thing is that you can use user agents. So you can say, if the user agent is Android, send it to this version, but if the user agent is iPhone, send it to that version, which is used for testing. And then, we already talked about this, so with failure handling, so you can set timeouts and retries, and then you can limit the number of concurrent connections and things like that. And And finally, fault injection. So if you have timeout 100 milliseconds and you retries 3 between these two microservices, and timeout 200 and retries 2 between these microservices, you can actually tell Istio, I want to introduce 5-second delay in 10% of my requests to V1 version of my service. So you can get really specific, and Istio will do that, and you can see what happens. Similarly, you can say, I want 10% of my requests to service V1 to fail with HTTP 400s. So you're simulating like HTTP 400 errors that happens occasionally and see what happens. This is very useful for testing because I never, like whenever I was doing this kind of stuff years ago, I would always try to guess what would happen, but now you can actually test it and write tests around it using Istio. So let's take a look at some of this. Traffic management, yes. So in this part, what I do is that first I create a new version of my application. So I change the Hello World to Hello World v2. Then I push the container image to Docker Hub. Then I create a new deployment for my application. So v2 deployment that's exposed behind the same Kubernetes service. And then I try to hit my gateway URL and see what happens. So let's do this. Right, so let me do CTL. And let's say service v1 and v2. So this defines the new v2 deployment of my service. So as you can see, service unchanged, deployment v1 is unchanged, but we created a new deployment for v2. And then if I do curl, I get v2. If I do another curl, I get v2. Then I get v1, right? Because what's happening is that both of these deployments, they are behind the same service. So when we go, it will basically pick one at random, right? But what if I want to test it out and I want to pin my v2 service, like I want to pin my service to the new version, v2 version. To do that, first you need to create what's called subsets. So let me show you this. So we will need to create a destination rule. So in this destination rule, so it's an Istio API. What we are saying is that this destination rule has name v1 and v2, and it's using labels version v1 and version v2. So we are basically creating two versions and associating those versions with the labels in Kubernetes. So that's how we are making the link. So let's create this first. Destination rule. And now what we need to do is we need to update our virtual service to use that destination. So if you look at this one, so this virtual service, now the only thing that we did here is that we are using the same host. So this is the same Kubernetes service, but we are saying subset v2. So this says use destination rule subset v2. So this pins to the version to our application. So let's do this. And this will update the virtual service. Enter. Okay, good. All right, this is updated, and then if you do the curl again, and you can see that it will always be v2, so we pin to the new version. So you can see that we are changing traffic dynamically, right? We are changing to new versions, we are creating new versions, everything happens dynamically, which is the power of Istio. Let's see what else I had here. So that's pinned to a new version. Traffic splitting. So let's say you want to test things out, and you want to send 75% of the traffic to v1 and 25% to v2 for testing, right? That becomes really easy in Kubernetes. So what you can do is you can create a virtual service wait. And in this virtual service, you say I want to create this route rule with this subset V1, and I want it to have weight 75%, and I want this subset V2 to get the weight 25%, right? By just specifying this, we can do that. So let's take a look. Virtual service, weights. So I'm again dynamic updating the virtual service, and then if I do curl, we get V2. We should mostly get V1 because that's 75%. See, maybe not quite, but kind of works. The next thing that you can do is fault injection. So what if you want to return HTTP 400 for 50% of the traffic to version 1, right? Again, the way to do that is in virtual service, you create a fault rule that says, I want for the 50% of the traffic, I want to return HTTP status 400, and I want to apply to version V1 for my service. So if we go back here, and do abort. Oh, sorry. And then let's do curl again. Now we got fault. Another curl, another fault. Then hello world. So roughly half of the time it should work, the other half you should get the errors, right? Which is very useful for testing. And finally, the other thing that you can do is you can inject delays in your service. So let's take a look at it here. So if you look at the delay, what I'm doing here is that I'm just saying I want a fixed delay of 5 seconds to 100% of the traffic to the version 1 of my service. So the traffic to version 1 will delay 5 seconds all of it, right? So if we do this, and let's just click this. And if I do curl, now it's like delayed 5 seconds. I can't blame the Wi-Fi anymore. It's it's Istio doing the delay, which is a good thing. This is the only time that the delay is good, I guess, when you're testing. But that's how you do the delays. And I think that's all I have in this part. Let's see if there's anything else. All right. Yeah. All right. Yeah, that's all my talk. So if you want so as I mentioned, the slides and the actual demos, they're all on GitHub. I just open source today for this event, so hopefully you'll find it useful. Yeah, and thanks for listening. I don't know if we have time for questions. We have? Okay, so we have time for questions, so if you have any questions, let me know.
For now.
Okay, thank you, Mete. So now we have the Q&A session. So we have souvenirs for people who ask. Okay, a lot of people asking. Okay, I'll count to 3. The first one. Okay, 1, 2, 3. Yeah. Oh yeah. Okay.
Okay, my name is Asran. I'm really considering using Istio and for our next big project. And there is slightly I don't still understand about Istio. Okay. How do we perform like service discovery in Istio, and we are using some kind of gRPC, is a communication between microservice. How does it perform in Istio? And Istio using some kind of proxy, right?
Right.
How do we communicate between those proxies?
Okay.
And one more time, we want to use continuous delivery like Cloud Spinnaker, that is compatible with Istio.
Okay, well, that's a lot of questions.
Sorry, thank you.
Yeah, so first of all, what was the first one?
Yeah, so, let me confirm. There are 4 questions.
Yes.
First is how Istio performs service discovery. That's the first question.
Okay, let me answer that one by one.
Okay.
Service discovery, it relies on Kubernetes service discovery. So basically, whatever the mechanism is in Kubernetes, it will ask Kubernetes for services copies. There's nothing special in Istio for that.
Okay. Next is how about gRPC?
Yeah, gRPC is supported in Istio. Yeah. So that should work.
And how about if we use continuous delivery like Scala Spinnaker?
Spinnaker. I mean, there's nothing special about Istio when it comes to like Kubernetes. It's just certain pods that run for Istio under Istio system namespace, right?
Yes.
So you can so in Spinnaker you can install Kubernetes and you can install pods. So it will be the same thing. Like there's nothing special about Istio.
There is nothing much different.
No, it's basically just more pods under the Istio system that makes Istio work. But that's it really. Like other than that, there's nothing special about it from the CI/CD perspective. And there was one more.
It is all? Okay, that's
That's
all.
it?
Yeah. This is the souvenir. Okay, for the next question, Giri will see and pick who is the fastest. Okay, I will close my eyes. 1, 2, 3. Which one, Giri? Mas baju biru ya, Bu?
Mas kotak kok.
Kotak-kotak. Oke. Ya.
Okay, my name is Dan. So, I sometimes when it comes to using Kubernetes and having implementing service discovery or traffic management, I'm kind of confused between using service mesh or IP gateway. So, would you enlighten us whether these two approaches can actually complement each other, or do we have to choose one or the other?
Yeah, I think so. API gateways and Istio, they will eventually work together. Because, for example, there's something called Apigee from Google, which is an API gateway, and it's doing some integration features with Istio. So if you have Apigee and if you have Kubernetes and Istio, then they kind of integrate together and work together. So I think API gateway is different than what Istio is providing. Istio is more about managing the traffic once the traffic is in your service mesh. And API gateway is more about how do you get outside traffic into your cluster, right? So they will, I think, eventually merge at the edge layer. So you have the API gateway at the outside layer. Then after that, will hand traffic to Istio gateway, and then from then on, will get into your cluster, right? So that integration today is kind of like not there. Like you have to set things up yourself somehow. But I know at least for Apigee, because it's from Google, they're doing integration work with Istio, and I'm sure there will be more going forward. So these two things, even though they're separate, they will eventually work together to make it simpler for people.
Yeah. Okay, this is souvenir. Yeah, the last question for this session, Imre will pick who gets to ask the question. Okay, again, one more time. 1, 2, 3.
Mas Afan.
Mas Afan. Nepotisme janjian. Monggo Mas Afan.
Hello, I'm at but how Istio compared to other solution for the because I work in IT infrastructure, because comparing the Istio when I see it as a proxy, right? How do you compare it with other proxy like F5 or the old proxy like or the new proxy like Nginx or Cetra, and also the other networking or security system that usually deploy in the infrastructure? How do you compare Istio to that technology?
Yes, I mean, it's hard to do a one-to-one comparison because I don't, for example, F5, I used it like 5-6 years ago at very, very basic level, so I don't know what happened since then. The Nginx, for example, there's a project where instead of using Envoy proxy, you can actually use Nginx proxy. So they're trying to kind of integrate with Istio. So what my guess, and this is just my guess, is that all these like complementary technologies, they will either kind of merge into Istio as features, or they will somehow integrate so you can use them together. But you're right, like it's a messy landscape because all these tools, they're doing bits and pieces of things, and maybe this tool does one thing that you want, but Istio does some other things that you want, and how do you integrate them, and which one do you use when? It's an open question right now. I think that landscape is still shaping up. So just like with container and Kubernetes, how it shaped up, and when Kubernetes first came out, there was question of what should I use? Should I use Kubernetes for containers, or should I use Docker Swarm, or should I use Mesos or something? But then eventually Kubernetes kind of won, and it's kind of the most popular now. I think in the same way, Istio will maybe move in that direction, or maybe something else will come along and it will perform better and it will dominate this landscape. But either way, I think there's a consolidation of all the technologies into bigger open source projects, and whether this happens with Istio or something else, we'll see.
Okay. That's all I think. But if you guys still have more questions for Mete or Dr. Imre, just stay in the room. We will have a hallway session after the hallway session. Okay. Thank you, Mete. Give
Thank you.
applause for Mete. Yeah. So now.